At 5:26 in the morning on August 10, 2025, more than 64 million cubic meters of rock separated from a cliff face above southeast Alaska's Tracy Arm fjord and fell 1 vertical kilometer onto the glacier below. The initial wave it produced was 100 meters high, taller than a 30-story building, and it traveled at over 70 meters per second, fast enough to cross a football field in under 2 seconds. The water it displaced ran up the opposite wall of the fjord to a height of 481 meters. That is 1,580 feet. That is nearly the height of the Empire State Building times 1.5. It was the second largest megatsunami ever recorded in human history. A cruise ship carrying 150 passengers was anchored less than 10 kilometers from the source. It was 5:26 in the morning. The cruise traffic had not yet arrived for the day. On a summer afternoon, that same stretch of water carries 6 or more vessels and thousands of passengers. The margin between the second largest megatsunami in recorded history and a mass casualty event was a few hours of sleep. The study documenting this event was published in the journal Science in May 2026. Most people had no idea it had happened. Tracy Arm is a 48-kilometer fjord in southeast Alaska, carved by glaciers over thousands of years into the granite of the coast mountains south of Juneau. It is one of the most visited wilderness destinations in Alaska. A narrow corridor of dark water flanked by cliff walls that rise more than 3,000 feet on both sides, home to humpback whales, harbor seals, black bears, and the South Sawyer Glacier, which calves icebergs directly into the fjord water at its upper end. During the summer season, it receives more than 20 vessels per day: cruise ships, charter boats, kayak groups. Alaska's cruise industry brought approximately 1.6 million passengers through the state in 2025, up from 1 million in 2016. An increasing proportion of them passed through Tracy Arm specifically to see the glacier. That glacier is why August 10th happened. And understanding why requires understanding what a glacier actually does to the rock it touches. A glacier is not just water in solid form. It is also a structural support. When ice presses against a slope for decades or centuries, it holds that slope in place, a buttress against the gravitational force pulling the rock toward the valley below. When the glacier retreats, the buttress is removed. The slope, freed from that support, begins to move. It moves slowly at first, measurably, in millimeters per day. And then, when a critical threshold is crossed, perhaps triggered by heavy rainfall saturating the fracture plains, perhaps by a shift in the internal stress state of the rock mass, it does not move slowly anymore. The South Sawyer Glacier had been retreating significantly since the early 1900s. In the months before August 10th, 2025, several hundred meters of additional retreat at the base of the slope had removed the last remaining ice support from a section of the northern cliff face above the arm. The study published in Science documented that the landslide was preceded by several days of microseismicity, tiny, barely detectable earthquakes within the rock mass as its internal fractures propagated. That microseismicity increased in rate and magnitude until approximately 1 hour before the collapse. Then, at 5:26 a.m., the slope let go entirely. The mass of rock that fell covered a vertical distance of 1 kilometer between the cliff face and the glacier surface. It then continued into the fjord water. The volume, 64 million cubic meters, is comparable to filling Madison Square Garden with rock approximately 3,000 times over. When it hit the water, it did not simply splash. It displaced the entire water column in that section of the fjord with the force of an explosion. The initial wave at the point of impact was 100 meters high. Moving at more than 70 meters per second, it crossed the narrow fjord and struck the opposite wall. The water climbed that wall to a height of 481 meters, stripping trees and vegetation from the granite surface as it rose, leaving a bare, pale trimline on the cliff face that was visible from aerial reconnaissance 3 days later and measurable to the meter by helicopter-mounted altimeter. That trimline is how the run-up height was confirmed: 481 meters, or 1,580 feet, of wave energy translated directly into vertical climb. To place that number in context, the world record for a measured megatsunami run-up is 530 meters, set at Lituya Bay, Alaska, on July 9, 1958, when an earthquake-triggered rockfall produced a wave that swept 2 of 3 fishing boats anchored in the bay over the tree line and into the open ocean. 5 people died. Tracy Arm, on August 10, 2025, came within 49 meters of that record, and did so without any earthquake at all. The cruise ship that was anchored 10 kilometers from the source at 5:26 a.m. reported being rocked by waves. Kayakers 55 kilometers away reported water rushing through their campsites and sweeping away equipment. A motor vessel 50 kilometers from the source observed visible surges moving rapidly through the fjord system. The wave had enough energy after traveling that distance and losing momentum to the fjord geometry to still produce measurable and physically disruptive wave action at distances comparable to driving halfway across a major metropolitan area. The seismic signal the landslide produced was observed around the planet. The initial collapse generated long-period seismic waves equivalent in size to a magnitude 5.4 earthquake, waves that were recorded at seismic stations in Hawaii, Greenland, Europe, Japan, and Central North America. But the more unusual signal came after the initial wave, a 66-second oscillation that persisted for up to 36 hours. This signal, called a landslide-induced seiche, is the fjord itself continuing to slosh, water trapped between the walls, bouncing back and forth at a frequency determined by the geometry of the basin. Researchers at Oxford University described the phenomenon precisely. Fjords, they noted, can act as giant tuning forks, with the resonance determined by their shape and geometry. The Tracy Arm fjord rang at 66 seconds continuously for a day and a half, and that ringing was detected on seismographs on the other side of the world. The SWAT satellite mission, designed to measure sea surface heights globally, captured the anomaly in the fjord 20 hours after the collapse and independently confirmed both the oscillation frequency and its persistence. This kind of seiche had only been recorded once before in a fjord, Greenland's Dixon Fjord, in 2023. Tracy Arm is now the second documented case. The researchers involved in the science study noted that the seiche's unique frequency serves as a kind of acoustic fingerprint, a way of identifying and locating a landslide tsunami event even hours after it occurs, at seismic stations far from the source. That capability is the beginning of a monitoring system. It is not yet a warning system. The community of Whittier, Alaska, a year-round settlement of approximately 200 permanent residents that hosts tens of thousands of summer visitors, sits at the end of Passage Canal, a fjord in Prince William Sound approximately 100 miles west of Tracy Arm. During peak tourist season, Whittier's population swells dramatically. The Trans-Alaska Pipeline System, which carries oil from Prudhoe Bay to the Valdez Marine Terminal and represents one of the most critical pieces of energy infrastructure in North America, runs to Valdez, a city of approximately 4,000 people also within Prince William Sound. The 1964 Good Friday earthquake, a magnitude 9.2 event centered near Prince William Sound, sent tsunamis through the sound that killed dozens in Valdez and contributed to the death toll of what remains the largest earthquake ever recorded in North American history. The landslide threat is different from the seismic threat, and in some ways more unpredictable. Barry Arm, a fjord 30 miles northeast of Whittier in Prince William Sound's northwestern corner, holds an unstable slope measuring approximately 500 million cubic meters, roughly 8 times the volume of the Tracy Arm slide. Scientists from the USGS, the National Tsunami Warning Center, the Alaska Division of Geological and Geophysical Surveys, and the Alaska Earthquake Center have been monitoring that slope continuously since 2020. An April 2026 update stated that while no large-scale deformation was currently observed, smaller instabilities remain, and the multi-agency team is working to maintain monitoring capabilities despite equipment delays caused by federal agency budget changes. Dave Snyder, Tsunami Warning Coordinator at the National Tsunami Warning Center, has stated the matter directly. Someday it will fall into the water. It is impossible to know just when it is going to happen. There are 3 signals scientists are now studying in the wake of the Tracy Arm event. The first is the precursor microseismicity pattern. The Tracy Arm study documents that the slope produced detectable microseismic signals for several days before failure, with the rate and magnitude increasing sharply in the final hour before collapse. This is potentially the most useful finding in the entire paper. It suggests that future similar events may be detectable in advance if the right monitoring infrastructure is in place. Alaska's seismic network currently provides some coverage, but the density of monitoring near unstable slopes in remote fjords remains limited. The second is the satellite data pipeline. The SWAT mission's detection of the Tracy Arm seiche 20 hours after the event demonstrates that space-based surface monitoring can provide independent confirmation of landslide tsunami events in near real time. The question being studied is whether the cadence of satellite passes can be reduced to minutes rather than hours, and whether the seiche signature can be detected rapidly enough to trigger a downstream warning. The third is the inventory of unstable slopes across Alaska's fjord systems. The Tracy Arm researcher Ezgi Karasozan has stated that Tracy Arm and Barry Arm are not the only fjords with dangerous conditions. Many fjords in Alaska have steep slopes, retreating glaciers, and conditions that could produce similar events. The Tracy Arm slide was, until August 10, 2025, an unmonitored slope. Nobody had flagged it. Nobody had put a seismograph on the rock that fell. The detection came after the fact. August 10th, 2025 happened at 5:26 in the morning. The cruise traffic arrived later that day, as it does every day. The trimline on the opposite wall of the fjord, the bare stripped rock from 100 meters to 481 meters above the waterline, is still visible in satellite imagery today. It will remain visible for years. It is the record of a wave that no one saw, that no system predicted, and that came within a few hours of becoming something else entirely. Subscribe to stay ahead of what's coming.